Hi there, welcome to the position vectors video that looks at as part of vectors in higher maths. We're going to look at two things today, how to define a position vector related to given coordinates and then use those position vectors to find the vector between any two coordinates basically. So far we can add subtract vectors, but given coordinates we don't have any kind of form of reference or know what's going on here. Now in here we're going to define position vectors. So the position vector is the vector that goes from the origin to a point. Now, because it goes from the origin to the point, the x-axis and the y-axis, the x movement and the y movement are going to be exactly the same as the coordinates of A. So if A was 3, 4, that means you go 3 across and 4 up. And for the vector as well, that would mean 3 and then 4. Same for any coordinate at all. The coordinate relates exactly to the vector, it's just written in a slightly different way. Okay, now what we want to do is you want to get a method not relying on the origin. We would like to have a method for going from A to B directly and being able to calculate what that vector is. Now, we know what vector A is here, that will just be related to the coordinates. We know what vector B is, that will be related to the coordinates. If I want to travel from A to B using only vectors I know, then I can go backwards down A, okay, backwards down A, and then forwards up B. Okay, so if I want to go from A to B, I would go backwards down A and then forwards up B. Okay, and then just to make that look a little bit prettier, I'm just going to rearrange that to B subtract A. So if I want to find the vectors between any two coordinates, all I need to do is do the position vector of the second of the destination from A to B, B is the destination, subtract where we started. Okay, so second subtract first. Okay, and that's there. That's your kind of note. If you want to copy that into your note, that would be excellent. And we'll do a couple of examples. Okay, so the first one, example one, R is a 0.25 and S is a 0.34. Find the components of RS. Okay, now using what we learned in the previous slide, RS is going to just be S subtract R. Now S, the position vector S, is going to be exactly the same as the coordinates, just in vector form, so it's 3, 4. Subtract R, which is 2, 5. So 3 subtract 2 along the top is 1, 4 subtract 5 is negative 1. So the vector RS is 1, negative 1. Example 2, let's look at some 3D, find the components of JK. So if I'm looking to find JK, I know, and this will very quickly become second nature, that it's K subtract J. K is just going to be 7, 0, negative 2 from those coordinates. Your position vector is going to be exactly the same because it leads from the origin. And J is negative 1, negative 5, 8. So 7 subtract negative 1 is 8, 0 subtract negative 5 is 5, and negative 2 subtract 8 is negative 10. So JK, that vector there, is 8, 5, negative 10. Okay, thank you. Any issues, ask your teacher.